Hello everyone, today we will discuss frequency response in control system. So the problem is when we are giving the sinusoidal input, what will be the response of the system. Okay, let's see it, what it will be. So I am considering a system whose transfer function is PS and input is a sinusoidal input. Okay, that input I am considering UT. Okay, and output I am getting YT, right? So I have to see this if I am giving input sinusoidal. So I am considering this PS, the response PS is equal to NS by DS, sum numerator by denominator, and I'm considering that this system is a stable system. It is a stable LTI causal seesaw dynamic system. Okay, that I am considering. Since this system is stable, so where should be its poles? Its poles must be on left hand side. Okay, so it should be like this: S P1 plus, right, and S plus P2, and then S plus Pn, right? So you can see all poles are on left hand side. You can see that all poles are on left hand side, which is a condition for the stability of a system. So this system is stable, right? And I'm considering the input signal UT is equal to U naught U naught. This I'm considering a sinusoidal signal. Okay, let sin omega t. Okay, and so what will be YS? Okay, I have to calculate output. Okay, I want to see the response, so output is equal to US dot PS, right? So what is US? So calculate US by doing Laplace transform of this signal. So it is U naught omega by S square plus omega square. Laplace transform of sin omega t is equal to omega by S square plus omega square, right? So now put all the values here in this equation. US we calculated U naught omega by S square plus omega square, and what is PS? PS is equal to NS by DS. Okay, so now let's do partial fraction of this. Partial fraction I am doing. So NS by DS equal to dot U naught W by S square plus omega square equal to A1 divided by S plus J omega. Why? Because I can write S square plus omega square equal to S plus J omega into S minus J omega, right? So and plus A2 divided by S minus J omega, and some numerator of this, and denominator ds. Okay, so this is done by part. Now we have to calculate A1, A2. Okay, and so to calculate A1, I want to calculate A1. For that, let us multiply all this by S plus J omega. Okay, after multiplication, what I will go? ns by ds, okay, dot u naught omega s minus j omega, right? Because this can I write, it can be written like this, s plus j omega, s minus j omega. So s plus j omega will remove this one, okay. So okay, and now equal to how much? A1, this is cut by this s plus j omega, and plus A2 s plus j omega divided by s minus j omega, and plus n1 s plus j omega divided by ds, okay. Now put s equal to minus j omega, okay. If I am putting this, what I will got on this side, minus j omega, right? So it is ns divided by ds into u naught and omega. This is minus j omega I am putting here, so it will become minus 2j omega, right? And equal to a1. And if I am putting here s equal to minus j omega, this will become 0, so it is 0. And here if I am putting s equal to minus j omega, this will also become 0. So the a1 value is equal to this, right? So I am writing this on this side. A1 equal to ns divided by ts equal dot u naught, minus I am taking outside, w divided by 2j omega, right? And this omega cancel by this. I can write it like minus u naught by 2j into how much? P minus j omega. Why P minus j omega? Because I am putting here s equal to minus j omega, right? So it is minus j omega, and this is also minus j omega, okay. So it can be written like this, okay, P minus j omega, okay. So my A1 is equal to how much? A1 equal to P into minus j omega minus outside I am keeping u naught divided by 2j, okay. This is my A1. Okay, now let's calculate A2. Similarly, multiply this whole by s minus j omega, okay. After multiplying s minus j omega, we will got ns by ds dot u naught and w divided by s plus j omega, right? Equal to a1 divided by s plus j omega, and s minus j omega is there, plus a2, and n1 plus n1 s ds, right? So now put s equal to j omega, so there also s minus j omega. After putting s equal to j omega, what I will got on this side, this can be written as pj omega, pj omega. Why? Because this term is ps, okay, and I am putting s equal to j omega, so it will become pj omega dot u naught w, and this is j omega, so it will become 2j omega, okay. This is cancel out, equal to this s equal to j omega, so this will cancel out, so this is 0 plus a2, and this will also become 0 plus 0. So what is a2? a2 is equal to how much? It is p j omega u naught 2j. Okay, so this I got a1 and a2. Okay, now see what is my ys. This is ys. Okay, this is ys. Now take Laplace inverse Laplace of this. Okay, so after doing inverse Laplace, you will got a1 e to power minus j omega t, right? Of this one, a1 is this, the Laplace transform is this, will be equal to e to power minus j omega t, and inverse Laplace transform of this will become equal to a2 e to power how much? J omega t. Okay, and the Laplace transform of this term will be equal to sigma I equal to 1 k sigma m equal to 0, and this is u I minus 1, and c m t m e to power p I t. Okay, so this is ys after taking the inverse Laplace transform. Okay, I got this. So if at t tends to infinity, at t tends to infinite, this term will become equal to 0. Okay, so limit t tends to infinite, ys equal to how much? It is, sorry, yt, this is yt. Okay, yt equal to a1 e to power minus j omega t plus a2 e to power minus, sorry, plus j omega t. Now put values of a1 a2 in this equation. Okay, so limit t tends to infinite, and this is yt equal to how much? A1 value I am putting. Okay, so it is minus u naught divided by 2j, 2j, right, 2j, sorry, 2j, and into p minus j omega, and e to power minus j omega t. Okay, this is this term, and now this I am writing, so it will become u naught 2j pj omega into how much? This a2 e to power j omega t. Okay, see this complex function p minus j omega can be written as, so pj omega I am taking, pj omega can be written as pj omega magnitude and the ej phi. Okay, where phi is equal to how much? pj omega. Similarly, p minus j omega can be written as pj omega and e to power minus j phi. Okay, so put these values here, will be equal to minus u naught 2j, okay, dot, and this will become pj omega magnitude, okay, and e to power minus j phi. Okay, phi is equal to phi equal to how much? Minus, sorry, phi equal to p minus j omega. Okay, so this is my this. Okay, and multiply by e to power minus j omega t, and plus u naught 2j, change this one also, j omega, and e to power j phi dot e to power j. See, this is a naught j phi plus omega t. Okay, now take common this and u naught. Okay, so after taking common, u naught pj omega, magnitude of pj omega, what will remain inside, 2j divided by 2j. Okay, and here it is e to power j omega t plus phi, and minus e to power minus j omega t and plus phi. Okay, so this is my limit t tends to infinite yt. Okay, after common, so now I can write omega u naught pj omega magnitude is equal into how much, you can write it like sine omega t plus phi. Okay, so this you can write. So finally what I am getting, so finally I got limit t tends to infinite yt equal to u naught magnitude of pj omega, okay, and into sine omega t plus phi. Okay, this I got. So this is my yt, steady state output. Okay, this is my expression for steady state output. Okay, see, what was my input? Input ut was equal to u naught sine omega t. Okay, so you can see the steady state output is a sinusoidal function. Okay, this is a sinusoidal function of some frequency. Okay, of some frequency, of the same frequency. You can see this is omega and this is also omega, so frequency is same. Okay, and there is scaling in this magnitude. Okay, scaling in magnitude, and there is some shift in phase. Okay, so we observe from this expression that the steady state output, the sinusoidal signal, this output, okay, output expression what have same frequency. Okay, this is the observation, same frequency, and it has some scaled output, scaled magnitude, and number 3, some shifted phase. Okay, shifted phase. So this is our observation from this expression of the steady state output. Okay, so the problem of our was when sinusoidal input signal I am giving to the system, what is the response of the system. So we got this expression for the response of the system, the steady state output expression, and we saw from this expression the observation is we got the same frequency, the response will be of same frequency, but the magnitude will be scaled and the phase will be shifted. Okay, so this is all about this topic, and this is our observation from this expression about the response of a sinusoidal input given to the system. Okay, thank you.